Dear students, now we will see the applications of optical fiber. This is the last topic of this unit. So the first application is communication. So from the beginning of the unit, we have been telling that optical fibers are very useful for communication purposes because optical signals are going to be sent only through optical fibers. So how it is done? So lot of communication devices are there, out of which we are choosing a simple one, telephone. So you can see in this picture a telephone at the transmitting end and another telephone at the receiving end. So the conversation between two persons, how that is getting converted into optical signals, and it is transferred through optical fiber and it reaches the receiver end. So that is the block diagram. So let us see here. So this is the transmitters, that is caller's end. Okay, so he gives the information in an analog manner, how we speak, that is in the analog form. So that is getting converted here. It is a coder, so it will get converted. So digital pulse, it is going to be converted to digital pulse. These are going to be generated here, and that will be sent to the light source transmitter circuit, where this will become optical signals. So these optical signals are going to enter into optical fiber. So we know by total internal reflection, the light will travel through the optical fiber and reaches the other end. So when it comes out, it will first fall on the light detector, which will receive the light and convert that into electrical signal, and that will be amplified by the amplifier, and then shaper circuit will filter out all the noise, and it will come out as the digital pulses, and then it will be sent to a decoder, where the digital pulses will get converted into analog output. So how the information is sent here, in the same form it will be received here. So here the optical fiber plays the biggest role. From the transmission circuit to the receiving circuit, what is running in between is optical fiber. So this is a telephone, which is something like a caller. So the analog information, that is the voice, is getting converted to a code. So it becomes digital pulses. It enters into the light source transmitter circuit, where it will be converted to optical signal, and this optical signal will enter into the optical fiber, and by total internal reflection it will reach the other end. When it reaches the other end, it falls on the light detector first, where the light will get converted into electrical signal, and that will be amplified further, and then it will get converted into digital pulses, and it will be sent to the decoder, where from the digital pulses the information will be filtered and it will be sent to the receiver end. So the key role is played by the optical fiber, because this is a small circuit and this is a small circuit. So in between what is running is optical fiber. So without loss, if we are making the light signals to travel through the optical fiber, then the receiver will receive the information without any loss. So this is the application of optical fibers for communication. You can see the content. One of the main advantage of optical fiber is communication. Like all other communication systems, the primary objective of optical communication system also is to transfer the signal containing information from the source to the destination. The source provides information in the form of electrical signal to the transmitter. The electrical stage of transmitter drives an optical source to produce modulated light wave carrier. Semiconductor lasers or LED are used as optical source here. The information carrying light wave then passes into the transmission medium, that is optical cables in this system. Now it reaches the receiver stage, where the optical detector demodulates the optical carrier and gives electrical output signal to the electrical stage. The common types of optical detectors are photodetectors, phototransistors, photoconductors, etc. Finally, the electrical stage gets the real information back and gets it to the concerned destination. So this is about the explanation of the previous picture. Next application is fiber optic sensors. So optical fibers are very useful for sensors also. All of us know what a sensor means. It is something like a transducer, which means it will convert one form of energy into the other form of energy. That is the transducer's role. So optical sensor, fiber optic sensor is a transducer which converts any form of signal into the optical signal in a measurable form. It is used to measure parameters like displacement, pressure, temperature, phase, etc. Now there are basically two types of sensors. One is intrinsic sensor or active sensor. The other one is extrinsic sensor or passive sensors. The photographic representations are shown here. Now, what is this active sensor? What is this passive sensor? Active sensor means an optical fiber, if it involves itself in the determination of a parameter, then it is called active sensor. Passive sensor means it will only help the sensor to work, which means it will simply act as a waveguide. It will not involve itself in the determination of any parameter. That is called passive sensor. You can see the content now. If the measuring parameter directly acts on the fiber, then produces the change in the amount of optical signal passing through it, then the sensor is known as intrinsic sensor or active sensor. Examples are temperature sensor, pressure sensor, liquid level sensor, intensity sensor, phase sensor, polarization sensor and wavelength sensor. Then extrinsic or passive sensor means if the measuring parameter does not directly act on the fiber, but it just transmits the optical signal and the fiber acts simply as a guiding medium, then the sensor is known as extrinsic sensor or passive sensor. Example, displacement sensor, laser Doppler velocimeter sensor, liquid level sensor. Out of this, one example for intrinsic sensor, one example for extrinsic sensor is there in our syllabus, which means we will be reading temperature or pressure sensor because for both the experimental setup is the same. And for the case of passive sensors, we are going to read displacement sensor. We will see it. Intrinsic sensor, that is temperature or pressure sensor. Let us go to the pictorial representation. So this is the laser source. This is a beam splitter. This is lens setup. This is optical fiber. Then this is mirror. Similarly, you can see one more lens setup and one more optical fiber and a mirror. And then some pattern, interference pattern is here. It falls on the traveling microscope and you are able to observe interference pattern. Now let us see what it is all. Laser source is emitting light which falls on the beam splitter. So part of the beam gets transmitted, part of the beam gets reflected. The one which is getting transmitted will fall on the lens setup L1. The one which is getting reflected will fall on the lens setup L3. Now, the light which falls on lens setup L1 will get converged. The parallel beams will get converged and it will go and fall on the optical fiber. By total internal reflection, the light will travel through it and come through the other end. Now this place is called reference place. So this fiber is called reference fiber. Why this is called reference means this is the outside medium where we are not going to measure any pressure or sensor. Okay, ordinary room temperature. So you call that as a reference. We are not making any measurement here. Then it falls on the microscope. Then let us come for the second part of the light beam, which is getting reflected from the beam splitter. It falls on the lens setup here and it gets converged. It enters into the optical fiber. Then by total internal reflection, it comes out of the optical fiber and it falls on the mirror where it gets reflected and falls on the traveling microscope. Now this is the environment where I want to measure pressure or sensor. So the path of the light which is traveling through this optical fiber and the which one traveling through the reference fiber will definitely have a path difference. So when two light are having a difference in their path and when they interfere with each other, they will definitely cause the interference pattern. So what is interference pattern? Alternate bright and dark fringes. So that pattern is observed. So how we are going to measure it is not our concern. The thing what we have to observe is we are using optical fiber for making the measurement. So where it is measured, there you are placing the optical fiber. So this optical fiber is actively participating in determining the parameter. So this is an example for temperature or pressure sensor. Okay, so after we get the interference pattern, applying suitable formula, we will find out the temperature or pressure. So here we are concerned only about the application of optical fiber. So we are not going to the calculation part. We are stopping only with this. Okay, so this is the active sensor construction and working. It may be a temperature or a pressure sensor. Now we'll go for the next one. Before that, we will just go through what is given. The reference fiber and the test fiber should be symmetrical in dimension and material. The path traveled by two beams should be of the same distance before the test fiber is subjected to temperature or pressure. The parameter, that is the parameter which is to be measured. The two beams after passing through the reference and test fibers produce a path difference when the test fiber is subjected to temperature and pressure. Thus, change in temperature or pressure can be accurately measured with the help of the interference pattern formed by the two beams due to path difference. We will move on to the extrinsic sensor or passive sensor, that is, it can measure the displacement. Okay, so in extrinsic sensor, two separate fibers of same dimension and materials are used. Let us see the picture and understand further. So this is the picture. You can see here two setups are shown. Okay, so this is for one optical fiber, one set of optical fiber. This is another set of optical fiber. They are placed coherently with each other. Now what is our target means we are going to measure some moving object. It may be a bird or it may be something which is moving. It may be a moving machine, something. We are going to find out the displacement. Okay, so we are going to send the light through the transmitting fiber. So by total internal reflection, it reaches the other end. It hits the target, gets reflected and enters into the receiving fiber. Once again by total internal reflection, it comes out. So by you are going to have a detector here and using appropriate formula, you are going to find out the displacement. Okay, so also by the intensity, with the help of intensity also we can find out the displacement. So here the optical fibers role is only it is acting as a wave medium, that is guiding medium. So through this it goes and through this it comes out. It does not involve itself in determination of anything. So this is an example for passive sensor. So this is the actual picture you can see. So light source, transmitting fiber, it hits the sensing area, it comes, reflects, it comes back, it enters into the photodetector where the optical signals are converted into electrical signals, further amplified, and you can calculate the displacement. Based on the intensity, that's what I said now, based on the intensity of light received, the displacement of the object can be measured. How means if the intensity received is more, then the object is moving towards the sensor. If the intensity is less, then the object moves away from the sensor. So if the intensity remains constant, then the object is immobile. So thus from the intensity of light received, the displacement of the object can be measured. Okay, so this is all about sensors. So we have seen communication, then sensor, and in sensor two types, active and passive. So with that I am closing this lecture session. We will see the next topic in the next video. Thank you.